Hello, all my people. How are you today? Okay, so today what we're going to be doing is we're going to be going through our renewable energy notes. And your note packet looks a little bit different than it has in the past. It's basically a series of questions. And as we go through the notes, I'll actually number where you can find each answer. So please pause whenever you need to copy down the answers as you see on the screen. In addition, rather than making many short videos, I'm going to break this up into chapters. So I'm just going to make one long video. You can watch the whole thing through if you want, or you can break it up into small individual chapters, and you can watch chapter one, then chapter two at a different time to fill in the answers. Okay, so that way you just actually go to the chapter 2 section on YouTube in the scroll bar. Okay? All right, so let's talk about, first of all, question number 1. What are some reasons to transition to renewable energy? So there's 2 reasons. First of all, pollution and supply. So this is your answer to question number 1, okay, is pollution and supply, okay? Fossil fuels give off greenhouse gases, and coal releases other air pollutants. In addition to that, we have supply problems. So we only have enough oil and gas to last 50 years, okay? So that's your answer to number 1, is both pollution and supply. And I would just copy down all the things that I actually just underlined. All right, but the thing is that renewable energy is not easy to actually transition to actually move towards renewable energy and only using renewable energy. It's quite challenging. So what are some of those problems? And there's no answers here on your notes. There's a couple different problems. Cost. While costs long term are lower, the initial investment is usually a very high cost. So putting solar panels on your house, while over many years you actually will get a return on your investment, the initial cost is very high, so that people really have trouble paying for that initial cost. Environmental impact, they're mostly pollution free, but sometimes they still affect ecosystems. Like wind turbines, for example, will still impact ecosystems. And then intermittency basically means that it doesn't always produce energy, does not always produce energy, okay? This is not an answer on your notes, but I want to make sure that. So for example, the sun, right? While the sun comes back every single day, we cannot produce active power at nighttime. That's all, okay? All right, so let's go to the first type of energy, which is hydrokinetic energy or hydroelectric power. So we're going under hydroelectricity on your note packet, okay? And this is energy from rivers and tides, all right? Okay, so hydrokinetic energy is basically, all that means is it's the movement of water. So the answer to number 2 on your note packet is that hydroelectric plants generate electricity by the movement of water. Okay, so let's talk about basically what happens. And so this is basically, this next slide goes through several different pictures. We add on to the picture each time. This is all answering to number 3 on your paper. Let's talk about the reservoir first, okay? The reservoir is basically an artificial lake. So you're going to copy this down. This is for A, okay? It's basically an artificial lake that's made to supply energy for the hydroelectric plant. So right here is this reservoir. We're looking at a cross section of the dam. Okay. The dam itself, this is the dam. It's basically concrete. Okay. And it holds the reservoir in place and controls how much water is passing through. This is for B on number 3. So this is blocking the water, and this area right here is where the water, this area right here is where the water comes through. It allows how much water actually passes through. All right. The turbine is this area right here. This is for letter C, for number 3. Okay, spins as water passes through it. So the water right here comes through down this little chute, and there's this wheel that spins sideways right there, and it spins the turbine as the water passes through it. The generator, this is for D, okay, converts the movement of the turbine into electricity. So the turbine converts, this is the generator, it makes electricity, which travels through these lines. Okay. Finally, the tailwater right here is, and this is for E, under number 3, is the river immediately downstream. So the water is flowing this way downstream. Okay. So there's a couple different problems with dams. This is number 4. Okay, this is the answers to number 4. This is A right here. A, reservoirs flood the ecosystem that was there before. So all this back here, right, used to be one giant river. But what they did was when they added this dam, the river basically stopped flowing and it flooded back and made this giant lake. So this is like a lake behind the dam, okay? Which is generally what a reservoir is. So okay, it's a lake that is artificial, right? So if you imagine yourself, if you like imagine water flowing off a table and you're stopping it at the edge of the table so it doesn't go into the floor, it will basically form a pool, right? That's basically what's happened here, okay? It forms like a pool behind it, all right? B, sediments. This is like sand, silt, clay, okay? All that stuff that as the river slows down, the stuff that was like basically carried by the stream, all like the debris, settles out and falls into the reservoir. The thing about that is this carries a lot of nutrients. So the nutrients get stuck in the reservoir. Okay? All right. Fish. Fish cannot easily travel between the headwaters and the tailwaters. It doesn't go through the dam. So fish can't easily travel between them. Nutrient levels in the tailwaters are significantly reduced. We can add this also to B. Okay, you can add that little information to B. Let me erase this lake part, okay? Sorry. So reservoirs are warmer and evaporate more. This is D. Oops, sorry. And then E, energy production, is right here. And let me erase some of this for you so you can see it. Oops. Okay, and this right here. Okay, there we go. There you go. You can see that better now. Okay, good. All right, so let's go to number 5. actually, this is number 6. So number 6 right here, pump storage. Skip number 5 for me. Pump storage are basically a second reservoir at higher elevations. So during times when there's lots of water, they will pump it up to a higher elevation. And when energy is needed, when energy is needed, when energy demand is low, we'll pump it up. Okay, low demand. When energy demand is high, water moves back down through the turbine. High demand. And because it's at a higher elevation, the gravity is going to make it fall really, really fast, and it will help spin that turbine even faster. So you can answer this with number 6. Okay. All right. Number 7. How is tidal power differently than river power? We do this along an estuary that allows water to enter during high tide. So this is actually, here's the ocean. Okay, it's between the ocean and the estuary. And basically during high tide, the water enters during high tide and goes out during low tide. So the dam is actually producing electricity as it passes through low tide. Okay. And what are some problems? This is for A, for number 7. Some problems that are associated with it are marine organisms cannot move back and forth between the ocean and estuary because this dam right here is blocking their movement. Okay, and it slows the normal flow of nutrients out into the ocean. Okay, and the ocean needs nutrients. So this is kind of a little bit detrimental to the amount of to the ocean ecosystem. All right. Okay, so let's move on. We are now starting chapter 2. Wind energy. So let's talk about how wind energy generates electricity. Wind turbines have 3, this is for number 8. Okay, they have 3 rotor blades that spin with the wind. All right, we're going to go through each part. So here's the rotor blades. Back here is a generator that immediately converts that electricity into electricity. This entire thing spins. It can spin in either direction. Okay, so the entire pole is actually changing direction to follow the wind. Okay, so this is direction. This is A. This is B. All right, and the following one is C. This is C. All right, the brakes halt the rotors. Okay, perfect. All right, so what are wind farms? They're basically, it's exactly what this looks like. It's a cluster of wind turbines that generates a large amount of power. Okay, that's what a wind farm is. This is number 9. Okay, each wind turbine, each one of these, a single turbine, will power 900 homes. So if you look at all of this wind farm right here, this can power a small city. Okay. Let's talk about the impacts of wind power. Okay. Each turbine, we'll talk about this. Number A. This is A. Okay. It produces 100 decibels of sound. Okay. That's so they can be quite loud. They have to be farther away from home. Okay. You just write what they're loud. Okay. They occupy a lot of land. This is B. Okay. C. They disrupt scenery. Okay. A lot of people don't want these near their houses because they disrupt a lot of scenery. Um, each turbine will kill 10 to 13 birds per year. This is D. And letter E. Oops, sorry. Yeah. Letter E is actually blank. Never mind. Okay, so let's talk about offshore wind farms. First of all, these are beneficial. They're more expensive, but they don't take up space and they're more productive because they've got fewer wind blocking structures. So these are out to sea and there's nothing blocking them. There's no mountains, there's no buildings, nothing to block the wind. So these will actually generate far more power. And this is for number 11. All right, let's continue on with chapter 2. Let's talk about geothermal power. All right, geo means earth. Thermal means heat. Okay, so we pump hot water from deep in the below the Earth's surface to form geothermal power, and this is a number 12. Basically, what happens is this. Okay, we drill a well. All right, that harvests steam from a deep reservoir. Okay, this is actually letter D. So we're going to start with letter D. Okay, it's drilled and it harvests hot steam from the underground well reservoir. So we do this, right? Um, then basically what it does is it goes up to the turbine. Okay, this is called the injection well. I'm sorry, this is called the production well. Okay, this is hot steam. The hot steam, just like in fossil fuel power, turns this turbine. Okay, this is letter B, to generate electricity. Generates electricity. Okay. What happens here is we can cool this down to release extra heat. So we cool the water down. All right, this is letter C. All right, and the cold water is pumped into, this is an injection well. Okay, it's pumped back into the ground. We're injecting it into the ground, and then the whole process repeats. Okay. Number 14. So geothermal plants have massive upfront costs. They can trigger earthquakes. This is, I'm sorry, for the number 14. Okay, they trigger earthquakes because you're removing a whole bunch of water at a time that can cause rocks to shift. And then this, because sometimes the water itself is near sulfur, sometimes this releases carbon dioxide and sulfur. It depends on where this is located. And this is letter C. Okay, so now we're moving on to chapter 3. Solar power. Parabolic means curved. Okay, so the first type of solar power is a parabolic solar collection. All right, solar collector. And basically what happens here is it uses curved mirrors. This is number 15. Okay, to reflect light onto a heat collector. Okay, basically what happens, like with anything else, we boil water, we turn it to steam, the steam turns a turbine that generates electricity. Okay, you see a theme. This is a giant parabolic power plant, solar collection plant. All of these are giant mirrors, okay? And they're all pointing towards the center here. The center is where all this energy, all the heat energy that's generated by this mirrors is being pointed at a tank of water to actually warm it up and create steam. So because of this, there's a couple problems with it. This is number 16, okay? Number A, energy production is intermittent. It means we can't create any. Decreases to zero at night. Energy production decreases to zero at night. Obviously, we can't create energy when the sun's not out. Okay. The upfront costs are very high. This is B. And letter C. Parabolic plants take up a lot of land. Okay, as you can see. So they need to be in big open spaces. This is photovoltaic. Photo means light. Voltaic means electricity. Okay. So photo means light. Voltaic is electricity. Okay. So this takes photovoltaic cells for number 17. It generates electricity directly from the sun without any moving parts. It's turning sunlight directly into electricity. There's no steam involved. A couple of problems with it. Drawbacks. This is number 18. A, energy production, again, decreases to zero at night. Okay. Upfront costs, again, very, very high. That's B for 18. C, they also take up a lot of land. Okay. This is C. But one good thing about it is that we're starting to be smart about it. We put a lot of them on roofs, but we're starting to use parking lots like this so cars can actually park beneath the solar panels. It kind of protects the car, to be honest with you. And then the parking lot itself can generate a lot of activity. There's actually one in Horsham that does this very thing. Okay, let's talk about renewable heat. This is a different type of geothermal energy, but it's called geothermal heat. Okay? Geothermal heat is basically, this is number 19, sorry, number 19. We use underground pipes to dissipate, this means lower, temperature in the summer, and then absorb heat in the winter from underground. Okay? So the ground itself stays a fairly constant temperature. It's about 55 degrees all the time underground. Okay, so it's cooler in the winter. It can be warmer than the air temperature in the summer. And then we're using this to actually heat the home. Passive solar homes. Passive solar homes is number 20. We collect heat from the south-facing windows in the northern hemisphere. Okay, and retains it in brick or stone. Overhangs like this or blinds will block it. Sunlight in the summer. Okay, so you got these big windows that will let light in the winter, and we'll go into much more detail in this when we do our project. But the overhangs here will actually shade it from this in the summertime. Active solar homes, on the other hand, are using a combination of solar panels. These are photovoltaic cells. These over here are not photovoltaic cells. You can see that they kind of look a little bit different over here. These ones, basically what happens is they pump cold water in solar collectors to the roof, and it's heated, and then pumped back into the home. So they actually use radiators, right? And these have like little coils like this of water basically running through them. The dark color will heat this water. And then they pump that water back into the home into radiators so that it heats the house. Okay? So it's a little bit different than the solar panels, which these make electricity. This is used for heat, these, these type of panels. Okay? All right. Biomass, number 22. Biomass is plant-based material to produce heat. We consider that charcoal, crop residues, energy crops, corn, switchgrass. We use all of these things to heat. Wood is considered a biomass. Okay? The biggest problem with biomass production is that it's limited by the growth rate of plants. And so if we use a lot of it, we can deforest areas. Okay? So we've harvested a lot of these trees on here, and this is now deforested because we are using that as a biomass fuel. Okay? All right, let's stop right there.